And so if you were doing just y equals the absolute value of x, it would look like that. And then the next one they gave you was absolute value of x plus 3. What does that do to your graph? Left 3, right? Left 3. And so you would go left 3, and you would do the exact same graph. It just shifts it. And so that's what we're talking about when we're talking about translating. When you translate a graph, you can shift it left, right, up, down, right? What we have done with amplitude is we have actually skewed it, stretched it potentially, right? So we didn't shift it left and right necessarily. We just made it taller potentially. That's what multiplying does. So if I had like one of these quadratics, the x squareds, a normal parabola is that perfect little u. Or if I have an absolute value, if I were to multiply this absolute value, it's going to pull it one direction, all right? What we did with period is we stretched it long ways or squished it long ways, right? We didn't necessarily make it higher or taller. We just stretched how long it took to cycle. And so we've done the amplitude, which will make it go taller or shorter. We've done period, which stretches it in or out. And now we're going to do shifting, where we actually, our starting and ending point is going to move. Normally our starting point is 0, 0, and our ending point is based on how long it is on period. Now we're going to translate them. We're going to maybe slide it left and right, and we're going to have a starting point here and an ending point somewhere else. We're going to slide it up and down, where we have a starting point not at 0, 0, but maybe up the graph or down the graph. And so that's why I keep referring to it as midline, back to your midline, because it's not always back to the x-axis when you go back to the middle point of your graph, because you could have shifted it up or down. And so that's what we're going to do with the sine and the cosine graph. If you start here on this first page, they talk about the fact that you've translated other graphs, and now we're just translating a period. So if you have something like this function here, which looks very similar to a sine graph, you can potentially slide it left and right. You can also take that same graph and just slide it up and down. The horizontal of the period is called a phase shift. So when you go left and right for a period function, it is called a phase shift. Phase shift. And so we've done these in other functions. We've done phase shifts with linears, where we go left and right, or with the absolute value like we just did at bell work, where it goes left and right. And what you'll remember with those, if you, from your bell work, we had plus 3, but we moved it left 3, right? Because inside the function, it goes the opposite of the way you would think it would go. The same thing holds true for your trig functions. If you go to page 744 in your books, we are going to look at translating the trig functions themselves. And I will say that I'm going to give you a little bit different take on these shortcuts, because it will not always be given to you in the format that they have given it to you in. So I'm going to give you another format really quickly as well. We've talked about amplitude. It's the absolute value. It tells you how far from the middle you're going to go. Period technically is absolute value as well. For that b, but it's 2 pi over b. It tells you how long it takes to cycle one time. Your phase shift and your vertical shift are within your standard function. They have, however, given you your b on the outside here. You see this right here? The b's on the outside. So the number in front of the x that would normally help us with our period is outside of the parentheses. More often than not, you will actually see these graphs like this. Okay. Most of the time that will be inside the parentheses. It does not affect period at all. You still use that b to figure out your period. But what happens to the phase shift, and actually on any other book that I have seen, this is actually C and D. So on yours, when you have your handout, I am fairly certain that I did it like this. So more often than not, that b will be inside the parentheses, which means when you get to this phase shift, you actually need to do C over b. And specifically, you need to do negative C over b. The reason you negate it is because just like any other function, when it's inside the parentheses, it moves you opposite. And so when you do a negative C over b, your final answer actually tells you whether to move right or left. Your phase shift is in the terms that it needs to be in. A negative will move you left, a positive will move you right. All right, so typically, and on my handout that I have for you today, that B is inside the parentheses, and you have to do a division, because if I were to factor the B out, right, it would also come out of that C. Does that make sense? And so if it's already on the outside, you can just use whatever that C is. Just negate it. If it is on the inside, if the B is on the inside of the parentheses, you have to do that division, okay? It changes your phase shift, which I think we saw that when we did it with parabolas as well. You had to divide, remember? With a parabola, if it was on the inside, you had to actually divide it out, and your shift was different. And the same is true for this. For vertical shift, it's already on the outside. On your handout, it is listed as A, B, C, and D. Whatever it is, it is. A positive will move you up on the graph, a negative will move you down on the graph. And that's how it's going to be for the shifting. All right, so let's do some of these. So amplitude is the number in front of what? In front of the sign. So my amplitude is 1. It's not going to shift at all. All right, my period, my period is just going to be pi, because I'm going to say 2 pi over my B, which is just pi. All right, my phase shift, what's my phase shift going to be? It's just actually going to be this guy right here, but we're going to negate him, right? So it's going to be positive pi over 3, which means which way is it going to shift, left or right? Remember, when you negate it, it actually shifts the way you think, right? Because we've already negated it. So it's going to go right pi over 3. And then my vertical shift. How's it going to move up and down? It's going to go down 3/2, right? You could say negative 3/2 if you want, or you can say down. If you wrote it as midline, and we'll talk about that with your handout, your midline is going to be y equals negative 3/2. Okay, and we'll do that when we actually graph it. All right. So let me grab the graph paper. So my midline is represented by that y equals, just like an asymptote in another function. It is a guideline. It is not part of my actual graph itself, if that makes sense. All right, it's just helping me figure out where I am on this graph. And so when I graph the midline, I am going to go to negative 3/2 or negative 1.5, and I am going to do this dashed line here. It is just a guideline for my graph that helps me know where I need to actually graph something. All right. The next thing I do is I figure out my starting and ending point for this particular graph. Normally for a sine graph, where would I start? Where would I start? At 0, okay? And so I would normally start right here, all right? Obviously I've shifted down, but normally I would start there, right? So normally I would start at 0 and I would go, if my period is pi, I would go to pi. Is that correct? But now I am shifting it. I am shifting it over by pi over 3. So I am no longer starting at 0. I'm actually going to start at pi over 3. Pi over 3. Now for this particular one, I use the back. So it's really just 1/3 of the way to pi, right? Pi over 3 is just 1/3 of the way to pi. And so you can see how many squares you have. 1, 2, 3, 4, 5, 6, 7, 8. And you can say, okay, 1/3 of 8 and do it that way. Or you can estimate it. I mean, it's fine. You know that pi over 3 is going to be somewhere between pi over 4 and pi over 2, right? Right? So we can put it somewhere in there. And so as long as you put it somewhere in there and you know, okay, I'm going to label it pi over 3. All right? If I shift my starting pi over 3, I need to shift my ending pi over 3. All right? I need to shift my ending pi over 3. And so this is no longer going to be pi over 3. This is going to be what? Pi plus pi over 3, right? Right? So 1 plus 1/3. So I have 4/3 pi right here. Everybody see that? So I'm shifting my starting and my ending over, right? That's what my phase shift does. So I now have my starting point is now at pi over 3, not at pi. And my ending point is at 4 pi over 3, not at pi there. All right? Any questions on finding your starting and ending? So you're going to start, where do I start? Add my phase shift to this, right? Where would I normally end with this cycle? This cycle is only pi, so I would normally end at pi, add pi over 3 to that. You're shifting your beginning and your ending. So if you need to like highlight, barely highlight, where would I start and end normally, and then literally shift each piece of it, you can do that, right? Now, once you have your starting and ending, you're going to do it exactly like you would. You're going to divide it in half, divide it in fourths, okay? Divide it in half and divide it in fourths. And so I'm going to divide it in half. I'm going to divide it in fourths, all right? And then I'm just going to do my sine graph. All right, my sine graph starts at my middle. All right, my middle is no longer at 0, 0. My middle is at this midline right here, correct? All right, now here's the thing. My amplitude is what?
1.
So 1 away from what?
It's 1 away from -3.
From -3 halves, 1 away from -1.5. So actually, my highest point is going to be at -1/2, because I'm only going 1 away from my midline, right? Halfway through, I'm back at my midline. 3/4, I'm 1 away from my midline. And then ending, I am back at my midline, all right? And so this graph is actually going to look like this. All right? So I have taken it, I have shifted it down. That's what it told me to do. I've shifted it over. That's what it told me to do. And once I have figured out starting and ending of that, I am literally just sketching my sine graph. You have to keep in mind, though, amplitude is not how far away from 0 you are. It is how far away from your midline you are. So if it tells me to go up 1, it means from the midline that I just found. If it had told me to go up 5, it would be from the midline that I found, not from 0. So you do that from your vertical. So to find your midline, you look at your vertical shift. Normally, you would do everything based off of your x-axis. Your vertical shift says move that middle line that you base everything off of down 1.5. And so I draw this red dashed line to tell me where my middle of my graph is. Remember, amplitude tells you how far from the middle you're going to go. So instead of going up to 3 and down to -3, I didn't do that. I just went 3 away from my midline. I went 3 away from here, 3 away from here. And that's how it told me my highest and lowest point of my graph. So I started at this middle line. I went 3 away from the middle line. I went back to my middle line. I went 3 away from my middle line. I went back to my middle line. Writing it, sine of x, that is pi units down. What's the only thing that's going to change there? your vertical shift, right? Which one's your vertical shift? Y equals sine of x. How would I say pi units down? Yeah, just minus pi. Minus pi. That's a vertical shift. Y equals negative cosine of x, 2 units to the left. How do I show 2 units to the left? To the left, I would go x plus 2. Remember, your phase shift is opposite. You use a negative of what's in there. All right? So you want to be able to see a graph and be able to tell how it actually changed. And I will say that you can be given a graph and you could write it in terms of cosine or in terms of sine, just depending on how you shift it. Because they're the same graph, they're just shifted. Right? So if you were to be handed a graph, you could potentially give me 2 different answers, one written as a sine graph, one written as a cosine graph. And it would be the same exact graph when you put it down. They want you to give all 4 things: amplitude, period, phase shift, and vertical shift. All right? So you're going to want to write out to the side just like I have been doing. You want to write amplitude. Amplitude is your absolute value of A. So what is amplitude? 2. What does amplitude tell you? How far away from your midline you're going to go. Okay? Period. Period is going to be 2 pi over B. So I have 2 pi over what?
1.
Over 3. Period. That's a tiny little period, right? It's going to cycle very quickly. All right, so then we have phase shift. Phase is negative C over B. So C is what? C is negative 3 pi over 4. So it's going to be positive 3 pi over 4, correct? All over my B. What is my B? 3. This is just division of fractions. How do you divide fractions? Yeah, keep, change, flip, right? So I'm going to keep the top one, change it to multiplication, and flip the 3. What is 3 when I reciprocate it? 1/3. So what is my phase shift? Pi over 4. Right? Pi over 4. My 3's cancel. All right? Keep, change, flip, right? And then vertical. Vertical's easy. Vertical's just what? 2. So I have answered 4 out of the 5 questions here, right? I have amplitude. I have period. All right. I have phase shift right here. And I have vertical shift right there. All right. I am now ready to graph my function. So I'm going to start out. I am going to start by graphing my vertical shift. I always graph my midline first. It doesn't matter how you do it. That's just my process. But, you know, whichever you want. So this particular one tells me that I am going to go up 2. So I'm going to go up to 2, where this 2 is on my graph, and I am going to graph y equals 2. That is my midline, the line y equals 2. It is not actually part of my graph. It is just a guide for what I need to do with my graph, okay? Now, then I am going to look at phase shift. Phase shift, all right? For phase shift, I usually start by putting my starting and ending, all right? So normally I would say, well, I would start at 0 and I would end 2 pi over 3. If you can't figure out where 2 pi over 3 is, change everything to common denominators if you have to. Common denominator between 2, 4, and 3 is going to be 12, right? Does that make sense? So I need to know where 2 pi over 3 is, 2/3 pi. So I have 1/4, that's going to be 3/12, right? I have 1/2, that's going to be 6/12, right? And then I have 3/4, that's going to be 9/12. Those are shown on my graph, right? I need 2 pi over 3. What is that going to be in terms of twelfths? 8/12. Everybody see that? So it's going to be really close to what? 3 pi over 4. It's going to be just before 3 pi over 4. Everybody see that? That would normally be my starting and ending point. You agree? But I have to shift it. Do I not? Yes. So I am going to take it and I'm going to shift it by how much? pi over 4, which is just basically 1 unit. So where I would normally start here, my new starting is going to be here. Okay? So I'm shifting it over pi over 4. That's my starting point. My normal ending point would be right here. I'm going to shift it an entire 1/4. So it's going to be now right here. So I now have my starting and ending point of this particular graph, right? So far, so good? Then you just cut it in half and cut it in fourths. I am not going to get a measuring tool out and make sure you did this correctly. You're welcome to eyeball it. It is a sketch. So I am going to pretty much just say, okay, that's about halfway. Okay, that's about a fourth. Okay, that's about a fourth. Honestly, that's what I would do here. Okay? So I've taken my entire period and I've cut it into fourths. And now I'm just going to graph. This is a sine graph, all right? Sine graphs start on your midline, don't they? So I'm going to start right here. At 1/4, I am at my highest point. My highest point is 2 away from where I am right now. So I'm going to go up 2, which is going to take me up to here. Halfway through, I am back at my midline. All right, so halfway through, I am back at my midline. 3/4 of the way through, I am 2 below my midline. And I end back at my midline. And so my graph is going to look something like this.